All right, if we take a look at our next question, number 6, a positive ion, is it larger or smaller than its parent atom? Well, let's take a look at an example of a positive ion. For instance, if we take a look at sodium, sodium, it turns out, has 3 shells. The first shell just has 2 electrons. The second shell has 2 electrons in the s sublevel, as well as 6 in our p sublevel. And then lastly, to get us to our 11 electrons, it has 1 more in the outermost shell. When it becomes an ion, like all good metals, it loses an electron to become positive. So now we only have 10 electrons, 2 in the nucleus, or not in the nucleus, 2 in the first shell, and then 2 in our s sublevel of our second shell, and 6 in our p sublevel of our third shell. I did a really bad job drawing this second shell. It really should be in closer to this. But as you can see, we're going from 3 shells in our sodium atom to 2 shells in our sodium ion. So therefore, we're losing a shell. So that's going to make our ions that are positive smaller. And that's because we've lost a shell. Alright, so these things, number 7, just basic memorization, elements in group 1. These are our alkali metals. And compare that to the elements in group 2. These are our alkaline earth metals. And then elements in group 3 through 12. These are our transition metals. They're transitioning from the metals on the left to nonmetals on the right. So as you go from the left to right across the periodic table, the elements go from being metals to nonmetals. The elements in group 17, like our example previously, these are our halogens. And we touched upon it earlier. The most reactive element in group 17 is the one who is the best magnet for electrons. The element that attracts the electrons the best is the one that has the electrons in closest to the nucleus, and that would be fluorine. Fluorine is the smallest element in the periodic table. Within its period, it has the most number of protons, and therefore that makes it super electronegative. It's a magnet for electrons. It's going to pull electrons in from somewhere else. The only way to do that is to react. So when things are reacting, they're involving their electrons. So fluorine, the most electronegative, the tightest holding on to its electrons. It's just a really good, well, it's a very strong reactive element.